This is section 12.7, solving rational expressions. In this section, we're going to look at how to solve for the value of a variable. So we're now looking to figure out what x equals, or what y equals, or whatever variable you have, whenever fractions are involved. Now, before we were just adding and subtracting fractions, and our answers had variables in them. But we're not going to do that anymore. Now we're going to actually solve for the variable. So when you see solve, okay, we're actually looking for a value of x. So we're going to look at two cases. The first one is when there's one fraction on each side of the equation. This is the monomial version. That means there's one term on each side. So it's really simple, one fraction on each side of the equal sign. So our example here has 6 over x plus 4, and that equals x over 2. To solve this, you have to cross multiply. So we're going to multiply 6 times 2 to get 12, and x times x plus 4 to get x times x plus 4. You want to multiply those terms out and then combine all your like terms. So when we do that, we get 12 equals x squared plus 4x. Then bring all your factors over to the same side. All your terms should be on one side of the equation so you can solve it. That's 0 equals x squared plus 4x minus 12. To solve that, you have to factor it. Okay, that's easily factored into x minus 2 times x plus 6. So in this case, we're getting two answers. We get that x is 2 and that x is, that should be 2, that x is 2 and that x is negative 6. Okay? You want to take your answers and plug them back into the original equations to make sure that they work, because you can often get extraneous solutions here. So you want to make sure they're not making the denominator equal to 0, that would make your fraction undefined, or that they're making your equation not be an equality. That is, it doesn't work. It's not equal on both sides of the equal sign. Okay, in this case, both negative 6 and 2 work and do not make the fractions undefined, so these are both answers that work, negative 6 and positive 2. Another example with monomials is this, 5 over y minus 2 equals y over 3. Again, to solve it, you cross multiply. So we get 15 equals y times y minus 2. That is 15 equals y squared minus 2y. To solve this, bring all your terms to the same side and factor it. So we get y squared minus 2y minus 15 equals 0. And that factors to y minus 5 times y plus 3. In this case, y equals 5 and y equals negative 3. You always take your answers and plug them back into the original equation to make sure they work. Make sure that you don't have anything that's extraneous. In this case, both your solutions work, so there are no extraneous solutions. When there's more than one term on one or more sides of the equation, so you could have two terms on one side with one term on the other, or two terms on both sides, the way to solve for the variable is to calculate the lowest common denominator and then multiply each term by the lowest common denominator. Right? So in this case, we have two fractions on one side of the equation, so this is the method we're going to use. In our example, we have x over x minus 2 plus 1/5 equals 2 over x minus 2. Look at the denominators here, as if you were going to add them. We see that the lowest common denominator is 5 times x minus 2. You want to multiply each term in this equation by the lowest common denominator. And when you do that, the denominator of each fraction is going to disappear. If the denominators do not disappear, that means you did not use the correct lowest common denominator. So be very careful here. It's actually a really good check. So I'm going to multiply everything by 5 times x minus 2. The first term becomes 5x. Then the second term becomes x minus 2. And the third term becomes 10, because you end up with just 2 times 5. That's 10. Put all your x's on one side, all your numbers on the other side so that you can solve in this case. So we'll have 6x equals 12 and x equals 2. You want to check your solution here. When x equals 2, though, look at that first fraction. The denominator becomes 0 and the fraction is undefined. So in this case, that is an extraneous solution. There are no solutions that work in this equation. Here's another example with more than one term. We have 2x over x plus 3 plus 1/3 equals negative 6 over x plus 3. In this case, the lowest common denominator is the two denominators combined, which is 3 times x plus 3. You want to multiply each term by the lowest common denominator. So you get 6x plus x plus 3 equals negative 18, or 7x equals negative 21, x equals negative 3. You want to check your answer. When you plug negative 3 back into that equation, does it make anything undefined? And does it make the equation work? In this case, the first equation, right here, is going to be undefined. So negative 3 is extraneous. There is no solution here. In example B, we have 3 over x minus 7 plus 1 equals 8 over x squared minus 9x plus 14. To find the lowest common denominator, you have to factor the denominator in that last term. So you can see what factors are there. When you factor that, you get x minus 7 times x minus 2. So the lowest common denominator is going to be a combination of that denominator and the denominator of the first fraction, x minus 7 times x minus 2. You want to multiply each term by these two terms. So you get 3 times x minus 2 plus x minus 7 times x minus 2, and that equals 8. You see how all the denominators dropped out here. Multiply all these terms out so that we can combine them. So you have 3x minus 6 plus x squared minus 9x plus 14 equals 8. Combine all the like terms. X squared minus 6x equals 0, and factor that to solve it. X times x minus 6 equals 0. Here you have two answers, x equals 0 and x equals 6. Plug both of them back into the equation to make sure they work. In this case, both solutions work. There are no extraneous solutions. We're going to look at solving a mixture problem now using these methods. Here's the problem. You have equal parts of yellow and blue paint totaling 8 pints. How many pints of yellow do you have to add to have a mixture that's 80% yellow? You're going to set P equal to the number of pints of yellow paint you have to add. That's what you need to find, so that's your variable. Now, in order to do this, you have to remember that a percentage is the part over the total. Remember that equation we had using amount over base? We said percentage is A over B, amount over base. So the smaller amount is always in the numerator, and the large amount is in the denominator. In this case, the part that's yellow is the smaller amount. That divided by the total amount of paint in the bucket should equal 80%, or 0.80. Because we know at the beginning there are equal parts of yellow and blue paint, and they total 8 pints, then you know at the beginning you have 4 pints of yellow paint. So the part that's yellow is going to be 4 plus whatever you have to add to it. So it's going to be 4 plus P. And the denominator, that's the total amount of paint, is the 8 that you started with, plus the P that you're going to add. So 4 plus P divided by 8 plus P is going to equal 80%. To solve this, because we only have one term on each side, we're going to cross multiply. So we get 4 plus P equals 0.8 times 8 plus P, and 4 plus P equals 0.64 plus 0.8P. So 0.2P equals 2.4, or P equals 12. Now remember what that means. We set our equation up, or our variable we define, so that P equals the number of pints of yellow paint you're going to add. So you just calculated that 12 pints of yellow paint have to be added to make this bucket of paint 80% yellow. That's the way you'll always do these mixture problems.